Hello, very good morning to all of you. Today we'll discuss the satellite communication part 1, and it is an introductory part. In the beginning, when the communication was taken place by ground wave and sky wave, the distance was limited about around 1500 kilometers. And that time there is no communication as today we are having. And after a long time, the television started, but it was very small number of city and very difficult to cover maximum population density. And that time, around 1945, one British physicist, Mr. Arthur Clarke, he was thinking how the television can be broadcast and it will be reached all over the world. Then in 1945, Wireless World magazine, he has put one journal named Extraterrestrial Relays, and there he has suggested that if one satellite can be put 36,000 kilometers away from the surface of the earth, then it can cover 1/3 of the earth. Similarly, 3 satellites can be put in 120-degree apart or near to the populated density area, and this orbit, the satellite orbit, will be parallel to the equatorial orbit, and it should move according to the earth rotation towards easterly direction, and the time period will be around 23 hours 56 minutes and 4 seconds for the sidereal day movement of the earth rotation. Then the satellite will be remain or look like stationary to any point of the earth. Therefore, any antenna which will receive the signal or transmitting signal to and from satellite will be remain stationary, and the communication will be take place, and even TV can be broadcast. But that time, how a big question mark, where is 36,000 kilometers away, and how can one satellite can be put there? Though electronic technology was available at that time, but transistor was invented around 1947, and around 1945, one rocket by Germany, it was able to go up to 2 kilometers from the earth. Then it was very difficult task. Still, scientists and engineers and some of the country, they started research and experiment, and finally Sputnik 1 was sent a low Earth orbit by Russia in 1957. There, the satellite era began, and from Russia and America, they have started competitive things, and many satellites have gone. And finally, in 1963, Intelsat Alibird was sent to the orbit, to the geosynchronous orbit, and the television was transmitted first time. Then this is the history of satellite communication. But how the satellite will be stay in orbit and how it can be sent to that geosynchronous orbit, regarding the celestial mechanism right from Copernicus, Galileo, Kepler, Newton and Einstein, all they have contributed maximum studies, experiment towards the mankind. Therefore, around, see that maximum Kepler and Newton has given this orbital mechanism a good shape. How the satellite can moving in orbit. In Kepler has derived the orbit, say this is Sun and these are any planet, and it will be move around the Sun and it will produce one elliptical orbit, and there will be two focus 1 and focus 2, and the same phenomena if instead of a Sun, Earth will be there, and any satellite like a man-made satellite can move and follow the same orbital mechanism. In this orbit, if only divided this axis, then this A will be major axis diameter and B will be minor axis, and from center of the earth to farthest point will be opposite distance RA, and nearest point will be perigee RP, and eccentricity will be E is equal to RA minus RP, RA plus RP, and when the orbit will become a circular, then E will be 0, and this Earth and the orbit, it will come to this center point. And Kepler has derived 3 laws. First law, it will have a elliptical orbit, and second law, from the center, whatever distance it will be covered by a certain time and produce whatever the area is equal, if this area will be equal to this point, the area, and same time, then it will be looked that in this farthest point the speed will be lesser and the nearest point the speed will be more. And third law says that the time period any satellite or any planet, whatever time period it will take, the period square divided by the major axis q is called to a constant, that is called Kepler constant. That is the third law, and that is second law, whatever I have told the area wise. Around 16th century, Kepler has derived all this formula or the laws in planetary motion, and after his demise in 1630, after 12 years, Newton has taken birth. And this 17th century, Newton has made some laws, what is called universal gravitations, that is say that if two objects will be placed in a distance of r, then whatever force between them will be generated, it will be gmm divided by r square. That means g is equal to gravitational constant and m is the first object mass and small m is the second object mass. And here, say we think that there is a geosynchronous or geostationary orbit, and here Earth is a major mass having capital M, and satellite will have a small mass m. Then whatever the force is generated, that is called centripetal and equivalent to gmm by r square. And the second law, it states that for this velocity of the satellite, it will be generated the centrifugal force, which is equivalent to m v square by r. And in this particular point, this 42,164 kilometers away from the Earth center, the two forces are equal and opposite. Hence, this satellite will be go on moving in the same orbit. And the first law states that any object will be moving or in stationary, it will be similar states unless any other force is acting to that. Therefore, this all Newton's law and Kepler's law are derived, and it will be helpful for the satellite and launching technology. And for this, the circular velocity will be g root over gm by r, and gm is equal to a constant, universal constant, and gravitational constant is equal to 6.6732 10 power minus 11 Newton meter square by kg square. M is equal to mass of the earth 5.9733 10 power 24 kg, and mu is equal to gm, the Kepler constant is equal to 3.986013 into 10 power 14 Newton meter square kg. And in any other point, the elliptical velocity is equal to root mu 2 by distance of the from the earth center to the orbit d, and a is equal to semi-major axis. Therefore, as per this law, now satellites are moving, and they have some 400 years back, they have derived all these laws for planetary motion, and in 20th century, around 1961, the satellite communication truly happened. And Clark was born in 1917, and he has expired on 2008, and he has seen whatever he has told after 20 years, or whatever he has put in paper after 20 years, one by one things are happened. Nowadays, we are having mobile technology, and communication is moving in a vast way, and the days will not far away that with this end of this century, man can start dwelling in moon or Mars or both, and other things. Though the scientists are looking for a second or any number of solar system, we may get any other solar system where other people or any living bodies are available. Therefore, now whatever that children around 1 to 5 years age, when they will become old, say around 70 to 80, they will enjoy all this new technology, and things will go on moving, and people will start about the space station now, which is already available by Russia and USA, and India also planning their own space station. Therefore, the whatever satellite communication we are seeing today, it has the in ancient period, these genius people have contributed so much that in this present society is enjoying one by one with this vast population, and we are seeing many things, say in a mobile. All things are available, and many works were carrying out which are nobody's imagined earlier, and many more things will come to picture. We hope it will happen, and this is just I have given introductory part of satellite communication. In the next part, we will go some other things of the satellite communication. I hope you might have understood some history part of this. Thanks a lot. Thank you.